Let's look at some examples, but first let me give you a few tips. So remember, we're typically creating a chain of reasoning, right? We have some statements, we use those to drive new statements, use those to drive new statements, so forth until we finally reach our conclusion. The way I typically think about it, there's exceptions to this, but the way I often think about it is I look at the end to see where I'm going. So I gave you an example that looks similar to this before, but I use different letters. So basically we had, A implies B, and B implies C, and A, and we used it to derive C. Okay? And I gave you this one because it's fairly simple to see that knowing A and knowing that A implies B, we get B, and now knowing B and that B implies C, then we conclude C. But in my head, I'm typically thinking of it this way. I say, okay, my end result is C. Where over here am I using C? Because whatever WFF includes C, that's probably going to be pretty close to the point where I would conclude C. Right? I'm basically doing this in reverse. I don't write it down this way. I'm just doing it in my head. I go, oh, B implies C, so that one probably gets used. Okay, so there's connects to C. There's a B. Now where's B at? Oh, well, here's B. Right? So there's how those two are connected. There's A. Where's A? Oh, I have A. This one, because it's so simple, once again, is basically the entire proof in reverse. Lots of others won't be that clear. Okay, but at least I want to know where am I going before I start trying to put things together. All right? So our first thing here would be look at end conclusion and work backwards. Like I said, it won't always be this straightforward, but at least it gives me an idea of which piece to start with, okay? Or at least think I do, right? Modus ponens gets used a lot. Remember we saw that on our sheet here, right here, that says given P, and that's what I used here actually, given P, and we can either write and or use a comma here, given P and P implies Q, conclude or derive Q. That gets used a lot. Okay. Another thing is De Morgan's. There's a couple of those, right? If I negate P or Q, that's equivalent to not P and not Q. So notice I flipped my symbol here, or became and. And if the inside had been and instead, then it becomes or. All right? So that means when you're given the one where the negation's on the outside, like this, you almost always then will replace it with the individually negated version. Okay? So oftentimes if I have that as one of these, I just go ahead and do that automatically because I figure I'm going to have to put use. Okay? And a fourth one I added here would be double negation gets used more often than you might think. It's easy to look at something like this and say, well, P negated is equivalent to P, right? So if P was true, not P is false, and not P is back to true, so it's just this. And it's easy to look at this and think, oh, it's really about simplifying, and so I'm just going to have this and go to this, which sometimes you do. But there's lots of times you actually go the other way. So for example, let's say we have modus tonens. Or tolens, excuse me. Right? And that says given P, that says give me this, that, P implies Q, and given not Q, then from this I can derive not P. And maybe what you have instead is this. You have A implies not B and B. Well, this really is just about taking whatever you have here and the negative of that, which is what I have here, and getting the negative of this. So I should be able to derive not A from this. But if you're doing a purely pattern matching process, right, where you're taking the sheet and trying to match things up, then it's not quite the same. But if I were to think of this, say, think that, that B is really B not, okay, well, then this is that negated. So it really is the same thing, right? So if I were to let Q here, so let Q equal B naught, then Q prime is B naught. Okay, that's what I have here. That's what my B is. So sometimes you have to rewrite it in terms of this, so then it matches the pattern. Okay? So that's the way I often think about those things. Let's work an example or two. So prove A naught implies B and B naught and A implies C, and all of that together implies C. Okay? So there's my P1 and P2 and P3 implies Q. That's in my right form. So I'm going to start by writing my hypotheses. This and this and this. So I have three things here. A naught implies B. B naught. A implies C. So think about what I said earlier. We'll write these down here. Hypotheses are given. My conclusion is C. So probably I'm going to use this one last. Okay, and that involves an A, so that's over here, but this is A and this is A naught, so somehow I'm going to have to make those match up. Okay, so that's another thing. I may be looking at my sheet, because I don't do this often enough where I've burned all these rules into my head. So I may look at this and go, well, what do we see here where things get flipped? Well, here's a P, here's a P prime. So maybe that matches up. Maybe my A, somehow I get A out of this or something, and get A prime over here or something like that. Or I look up here at contraposition. P implies Q is equivalent to Q prime implies P prime. Now once again, you may look at that and say, well, yeah, but you have a prime on one of these but not the other one. But really all this is saying on contraposition is you take the P and the Q, whatever they are, swap their sides of the implication and negate whatever they originally were. Okay, so I'm looking at these kind of things and getting some ideas. All right, so what would I do next? Well, maybe I do this. I do the very thing I just said. Okay, so contraposition says negate this, so that's A naught, so that'd be 1 in contraposition. This then becomes B prime. I can simplify this just to A. Now, could I have just done that, realize that this would just become A? Sure. I guess it depends on who's grading your proofs, okay? Now, for some of these things like that involve double negation or commutativity, lots of times I'll just sort of do them in my head, just jump straight to that step. But if I'm being very anal and trying to show you essentially everything that's being done, then I would have this extra step. All right, so what we have now? Well, there's an A, and remember we said that I knew to get C, I'm going to have A. Well, there's my A. There's B prime. There's a B prime, so I can take 2 and 5 and modus ponens. All right? So where are we at? That. 1, 2, 3. So I would get A from this because I take this and conclude A. So that is number 2 and number 5. Modus ponens. And now I can take A and A implies C and modus ponens and get C. All right? So that was 3 and 6, modus ponens. Okay? Is that the only way to do it? Well, not at all. Let's try another one. Let's look at the other version. So I'm still have 1, A implies B, 2, B prime, 3, A implies C. So hypothesis, hypothesis, hypothesis. Right. So I may look at this and say, here's B prime, here's a B. So if I look at my sheet, I can see here from modus tollens, P implies Q, and given the negative of Q, A prime implies B, and the negative of B, it's looking like that pattern. Then I can derive not P. So that means given 1 and 2, I can get not A. So this is 1, 2, modus tollens. Simplify this, just A, so this would be 4, double negative. So now we'll have A implies C, that's 6. So I get C from 3, 5, modus ponens. So this one took 7 steps, this took 6 steps. Maybe there's some other versions. So you'll find that these are kind of like algebra problems. You know, why do you do it in the order you do it? Well, in many cases, you just chose it a certain way. There may be other legitimate ways to do it that are basically equivalent. Now, there may be other legitimate ways to do it where they're widely different in terms of how much effort you had to put into it. Okay? But this is one way of doing it. Or these are actually, two different ways of doing it. So really this is the one that took less steps, but hopefully both of these make sense to you. Okay? Let's look at another one. Prove P implies Q and Q implies P implies P implies R. Or excuse me, this is R. This is R here. All right. So what we're showing here, this was, if you look at my sheet, this is we've already found this is true. So this is going to be something called hypothetical syllogism. Once again, looking at my sheet, right here, hypothetical syllogism. Given P implies Q and Q implies R, we can get that P implies R. All right? So what do we do? Well, 1, we have P implies Q. 2, Q implies R. These are both hypotheses. So hypothesis, hypothesis. Now, some authors, in particular Gersting, which I have the most experience with, Gersting, uses something called the deduction method, which basically says we can pull this P over here as an additional hypothesis and just have the single implication. So now when she does her examples, she would write P and simply just write hypothesis. I like to write deduction method. And also I like to also write that I now have P implies Q and Q implies R and P, all that together implies R. So now I'm looking at going, okay, this is what I'm really dealing with. So that's where the P comes in. So it is another hypothesis if you know to do that. Okay? So now what can we do? Well, now just go through the chain of things, right? I can get Q by taking P and P implies Q, so 1 and 3, and modus ponens. And now to have Q and Q implies R gives me R, so I use 2 and 4 in modus ponens. And this is how we got this. And you should be able to also create a truth table for this, but given that I have 1, 2, well, 3 different letters here. That's going to be 8 different combinations of true falses and a lot of writing to work my way up to it. I would argue this is much simpler. And this also will lead into some other things we'll do later, where the only reasonable way to do it is to reason your way through the sequence of steps. Okay? So those 2 examples. We'll do some more in another video.